Hey, folks, and welcome to Shop Talk number 25. I'm your host, Robert O'Brien, enjoying a nice cup of coffee, compliments of the Acoustic Coffee Company. Today we got a special guest who'll be showing up here momentarily, and that is going to be Mr. Trevor Gore, all the way down there in Sydney, Australia. For you folks that like coffee, here's a little coupon code for you. Robbie-O. That will get you a free bag of coffee with your first purchase from acoustic.coffee. Go ahead and check them out. They make fantastic coffee. And thanks for tuning in again. Please go ahead and put in your comment section there. I'm getting an echo here for some reason. All right, go ahead and put in the comment section there where you're from, because I always like to read those. And today is a little different time because of Trevor. He's all the way down there in Sydney, Australia. And so it's like 9 o'clock in the morning for him. So I appreciate him getting out of bed early and coming and spending some time with us here. And so I don't know how many people we're going to have on here today because it's a little different time. Thanks for tuning in, though, and thanks for Jim Deeming for supplying that wonderful music there for us. The intro music that I use. Let's see. I'm getting an echo here. Somebody got their sound turned on there? Either Trevor or...
I think that might be Jane's phone going off.
Oh, that's Jane's phone going off. All right. I think, wait a minute, that sounds kind of weird. All right. So we're going to have a drawing here in a few minutes, and I'm going to bring on Cesar and Manuela all the way down there in São Paulo, Brazil. There they are. There's Cesar and Manuela. They're becoming quite famous here on the live streams. And Cesar, if somebody wants to enter, wait a minute, you're in my shop again. What is that? That looks so weird. They're using a green screen. They're using my shop as the backdrop there. For those people that want to enter the drawing, how do they do it, and what are they going to win today?
Yeah, so I just left a link in the chat box, and all you have to do is follow that link and leave your name and email, and we will pick randomly some winners from the list of people.
All right, and we're going to be doing that here in just a few minutes. So I'll come back to Cesar and Manuela when it's time for us to have the drawing. So see you in a few minutes.
See you.
All right, some more announcements here. Put in the chat box where you're from. I'd love to see that. Already have people showing up here. We got Reed Johnson Reed there in Castle Rock. That's just south of me here, just a few minutes. We got Tim up there in Oregon. Let's see, we got California, all the way to England. Wow, thanks for showing up. Appreciate that. We got all the way in New York there as well. Let's see, Brunswick, Georgia. That's down where I grew up, down there in Atlanta, Georgia, where I grew up. Jack from California. Numero uno, I don't know who that is, but there they are. And John Helton, he's right here in Colorado. All right, thanks for tuning in, everybody. So a couple of announcements. I don't know what I did there. Hang on just a second. All right, a couple of announcements here. If you guys are into discounts, I've got discounts. LMI is having a discount, 10% off until October 31st. And you have to use the promo code ADAMS, ADAMS 2022. So go to LMI's website, www.lmii.com. You get 10% off your purchase until the 31st. StuMac also is offering all of the Luthery Academy viewers here 10% off. I've put the, Cesar, correct me if I'm wrong, but I think I put that somewhere in the chat box before we started here. If not, see if you can find that and put it up there for me, Cesar. The 10% discount for StuMac ends tonight, October 14th. Midnight Eastern Standard Time. So you guys, if you're interested in the 10% discount from StuMac, go ahead and get on that. Also, in honor of Trevor Gore, who's going to be on here in just a few minutes, I'm offering 10% off his newest course, the Falcate bracing course. Just go out to the Luthery Academy website and go on the Falcate course, and then at checkout, make sure that you use Falcate, Falcate, and that will give you 10% off. All right. And as usual, I always like to call attention to my website real quick. So here's the new Luthery Academy website. All things Luthery related, and it's the online portal there, folks. So go ahead and check it out. There's always things being updated and changed. So if you're into Luthery information, this is the place. We're in the process of migrating all of my content, all of the videos from guitars over to Luthery Academy, and the video page will be over there shortly. Also, I want to call attention to my sponsors here. And we have Luthier's Mercantile. We have the Acoustic Coffee Company, the Duke of Pearl, StewMac, Pacific Rim Tone Woods, Glue Booth, and Elevate Luthery. So thank you very much for them. And if you need some of their products or services, please make sure you find a way over to their website. Pacific Rim Tone Woods will be our next Shop Talk live stream coming up here in a couple of weeks. I believe it's going to be on the 26th, Wednesday the 26th. At 10 a.m. Mountain Time. And if you're not familiar with Pacific Rim Tone Woods, if you go check out their website, Pacific Rim Tone Woods, you'll see there that there's a couple of videos you can click on, and those were made by Trevor Gore, by the way. So you can check out their website. They are tone wood suppliers, and they also do sonic testing on their soundboards. And they're going to show us how to do that, or at least explain it to us, coming up here in a couple of weeks. So October 26th, 10 a.m. Mountain Time. All right. I think it's time to bring the man of the hour on here. That would be Mr. Trevor Gore. Let's see if we can find him somewhere here. If I just click the right button. Let's see. There he is. All right. A nice round of applause for Mr. Trevor Gore. Come on, folks. Do a little bit better than that. There we go. Trevor Gore. You're not on the beach this time, Trevor.
Sorry?
I said you're not on the beach this time.
No, I'm not in my workshop at the moment. I'm having to move somewhere where there's a bit better broadband connection so we can get this video streamed live.
Oh, fantastic. Well, thanks for getting up early. For those that don't know, it's 4 o'clock in the afternoon here in Denver on Thursday. It's 9 o'clock in the morning on Friday over there for Trevor. And that's why we're kind of doing this Shop Talk live stream at an odd hour, is so that we could accommodate the schedules. And we've got Cesar and Manuela down there in Brazil, and it's 7 o'clock in the evening for them. So this is really, this is a lot of technology going on here. We're getting all three of these different time zones going on at the same time. So hopefully we can pull it off. Look at that. We got somebody all the way over there from Greece tuning in. Look at that. Holy cow. And Paco over there in Spain, the secret is out. Well, here come all the secrets in just a few minutes. Trevor's going to give us some secrets. If you guys have any questions during the live stream, make sure that you go ahead and put it in the chat box. I'll try and get to it as soon as I can. So, Trevor, you ready for a question? Let's just go ahead and get started here, huh?
Yeah, let's go for it.
Here we go. And this one, by the way, is from Sydney, Australia. Somebody sent me an email today and said, hey, make sure you ask Trevor this. How does Falcate bracing compare to other bracing when it comes to the dreaded effects of humidity, both during the build and after the guitar has been built, seasoned, and played? And that came from Steve all the way down there in Sydney, Australia. So is there any difference with the effects of humidity in Falcate bracing, Trevor?
Well, certainly when you're building the guitar, you need to keep it under humidity control. So typically somewhere between 40 and 45% relative humidity is the best for building probably any sort of a guitar. And certainly if you're building Falcates, you need to observe that rule as much as anything else. Now, after the guitar's been built, the Falcate bracing system does have a number of benefits in terms of response to humidity. One of the major differences between Falcate bracing and, for example, X bracing or lattice bracing is that there are less continuous braces going directly across the grain. In X bracing, of course, the X braces go across the whole width of the guitar. In Falcate bracing, really the only brace going across the width of the guitar is actually the bridge itself. And the consequence of that is that as humidity changes, the top pumps up and down a lot less than both X-brace and lattice brace guitars. And what you'll actually see in extreme cases of humidity, it actually looks like the top has dipped down. It actually hasn't. What's happened is that the outboard edges of the guitar, where the secondary Falcates are, because the secondary Falcates are across the grain, they tend to bulge up a little bit. So you get these sort of two bulges either side of the bridge, which actually makes the bridge looks like it's sunk, but it hasn't. It's just the outside parts that have risen a little bit. The consequence of all of that is basically nothing, because the action hardly changes at all. Whereas on a cross-brace guitar or a lattice-brace guitar, as the humidity rises, the top pumps up, and the consequence of that is the action raises. So, cutting a very long story short, Falcate bracing is fairly impervious to humidity changes as far as the playability of the guitar is concerned.
Fantastic. That's interesting to know. That's one thing. I learned something new today. I hope everybody else learned something new. I didn't know that. So thanks for giving that answer there. I see quite a few people from Australia tuning in. So I guess we've chosen a good time for all the folks down there in Australia. So that's great. A little background on the Falcate bracing, Trevor. How the heck did you come up with that, and why the name Falcate?
Well, let's start with the Falcate name. We've got these curved braces, of course, in the Falcate system, and there's, coming from Australia, there's a great temptation to call it something like boomerang bracing, but that, of course, is a bit obvious. So it was actually Michael Pemberthy, whose picture appears in the back of the build book, tuning up a guitar. He's one of the guys who works with Gerard at his workshop at Botany at the time. Great guy. And Michael's one of these guys who, he actually lives quite a long way from Gerard's workshop, and goes up to the workshop every day on the train, or he used to anyway. And it was about a 3/4 hour train journey, consequence of which is that Michael has read everything. And when I say everything, I mean everything. And I'll tell you a short story. One day, an English professor who was a guitar player wandered into the workshop and was playing a guitar. He was there with the intent of buying a guitar, and he was talking to Michael and made some literary reference, and Michael responded to that, the consequence of which they ended up in a very deep conversation about English literature that was way beyond the realms of most people. And Michael eventually left to do some spraying and asked Gerard, who the hell was that? Michael, he just reads a lot. So when we came to looking for a name for that bracing system, first person to go to was Michael, because he's read everything. And he said, Mike, what are we going to call this bracing system? And he went away. He said, give me a couple of days. And he came back and said, well, how about Falcate? And Falcate actually means sickle-shaped. So if you look at the word Falcate, you'll very often see it used with reference to leaves of trees, which are sort of curved like a sickle. So Falcate actually means sickle-shaped. So that's where the name Falcate came from. And we thought it'd be better than boomerang bracing. Now, in terms of how I came up with that, many years ago, when I was doing a lot of sailing, there was a system of reinforcing sails on boats, on sailboats, called tape drive. And it was the precursor to the 4D sails made by North Sails. And I think tape drive was originally designed by a guy called Ulmer Coleus. And what these did was put high modulus material, I think it was Kevlar at the time, stitched onto the sails as a sort of tape that went down the stress points of the sail. So if you imagine a triangular sail, these curved tapes were stitched from the corners of the sail in a curve. So they went from one side to the other side of the triangle in a sort of curved shape. And they were there to take the stresses the maximum stresses of the sail. And I looked at this, and being an engineer, I was thinking, I look at X bracing, which is the common form of bracing in steel string guitars, and you just look at it and you think, why? Why would you do it like that? Why not put the material where the maximum stress is and rationalize the design so that you just put the stiffness where it's most required? And it was a combination of those two thoughts, the curved tapes on the old Macolius sails and the concept of putting the material where you need it most to make an efficient structure, that basically is where the Falcate shape came from.
Right. Now, just for those that don't know, and I imagine everybody on the broadcast knows this, if you're interested in doing the Falcate, there's two ways to learn the Falcate bracing. One is to get Trevor's books. And let me see if I can just pull those up here real quick for you, Trevor. Let's see. If you go over to, I click on the website here, and it takes a little bit longer because it's all the way down there in Australia. But if you go over to Trevor's website, Trevor Gore Guitars, or goreguitars.com.au, because he's in Australia, there's a tab there at the bottom you can click on called The Book. And it will give you all the information about Trevor's books. He has two books, the design book and the build book. And in the back are some plans for some Falcate bracing. And so you can go ahead and learn how to do the Falcate bracing. That's one way. The other way is the course that Trevor just launched with me, the online course available at the luthiacademy.com. Just click on the online course there. In fact, let me just pull that up here. I can show everybody a picture of that. Because everybody's picture-oriented these days, visually oriented. And so if we go over here and look, there's the Luthery Academy website and Falcate bracing. And you can disregard that price of $177 there because it's 10% off if you use the promo code Falcate for the next 3 days. For those that aren't watching live, I always got to put the date in there. But that's what it looks like. It's a fantastic bracing system. And by the way, for those that are interested, I've got the very guitar that Trevor built here in my shop when he was here just, it was back in July, right? That we used to film the Falcate bracing course. There it is. And it doesn't have bindings yet, but there's the guitar. And that guitar is for sale, by the way. It's got the Falcate bracing done by Trevor. It's got the live back. If you know from his books, he talks about the live back. He's got all that braced. It's got it tuned to the frequencies that he mentions in his book. And that is for sale, by the way. So if anybody's interested, go ahead and contact me through my email address or something, and we'll set you up with that if you're interested. Trevor, we've got a couple of questions coming in here from the chat box here. Let's see if we can pull one up here. What are some options if the main top frequency is below your target after closing the body but before finishing? Oh, that's good. You might want to give them a little bit of background on what they're talking about, frequencies there, if that's okay, Trevor.
Sure. There are a few frequencies which work well on a guitar. Basically, they're the frequencies which are exactly between scale tones. So if we're talking about steel string guitars, for example, 170 hertz, 180 hertz, 190 hertz are good frequencies for the main top resonance. That's what I call the T112 resonance. On a classical guitar, they're usually a little bit higher. 190 hertz is a really good number for classical guitars. Now, if you've built the guitar and you've got it boxed up, and the resonances are on the low side, it depends really how low you've got. You might be able to rescue it by putting on a really low mass bridge, because the bridge adds both stiffness and mass. What you need to bring up the resonant frequency is to add stiffness or reduce the mass. Now, the problem with working on the top itself, if you start off too low, is that removing material is going to remove stiffness faster than it removes mass. So all you're left with as an option really is by making the bridge very stiff and very, very light. So you might be able to get there raising the frequency by putting a slightly wider bridge on than you normally would, but making sure it's very stiff. So the way to do that is to laminate carbon fiber into your bridge to stiffen it up. but make sure you're using a fairly low density wood to keep the mass down, and thin it out as thin as you can at the back edge. If you're way low, really you don't have too many options, but it really depends on where you are to start with, of what low is. I mean, certainly there are plenty of guitars around with resonances of 160 and 170, and a 170 T112 on a triple O size guitar is actually quite a nice sounding guitar. If you're down at 160 for a guitar of that size, that's probably a bit problematical. It's probably going to sound a bit muddy. So if you're still stuck and you're really way too low, best thing to do is cut your losses now and just chop the top off and put a new one on.
Start over, right?
As it sounds.
So it's easier to go down, it's harder to go up, in other words.
Yeah, it's a lot easier to go down than up, that's for sure. So, general rule is always aim a little bit high of your target, give you an opportunity to come down to it, because going up is pretty tough.
Okay.
And if you're too high as well, coming down a long way is going to be problematical as well. Because coming down a long way usually means you have to mass load it. And mass loading is never a really good idea. You want the top to be as light as possible, to be as responsive as possible.
Right. Speaking of mass, anybody who is familiar with your work and the books that you have, you put side mass. You put a block of metal on the sides there. And I remember you telling the story here in one of our modal tuning classes about the coins, the Australian coins, and how you kind of stumbled upon this theory and how you proved it. Care to elaborate on that?
Well, there's two stories about coins, so I'll tell you the first one. The first story about coins is when I came across this issue of side loading. I was building a guitar at the time and had it in its outside mold. So there's about 4 or 5 kilos of material around the outside of the guitar. And I was tapping the top and noticed that the top was a much lower frequency than it had been when it wasn't in the mold. And I thought, oh, why is that? And so I started messing around. So I thought, well, look, if the issue is with it in the mold and outside the mold, there's just two things the mold could be doing. It's either adding mass to the sides or it's adding stiffness to the sides. So which is it? So I found a whole bunch of 50-cent coins, which is the largest of the coins in Australia, the heaviest of the coins. And I stuck all those all over the sides of a guitar, basically just adding a lot of mass to the guitar using blue tack to add those coins, and found that the resonant frequency of the top went down. I thought, that's interesting. So a bit more explanation demonstrated that it was a mass effect and not a stiffness effect. And then I was also writing the 4 degree of freedom model about the same time, which had the influence of the sides in there as well. So I was able to model it and show that the effect was actually a real effect, and the mathematics indicated that as well. So it wasn't just some rather strange apparition that was going on that particular guitar. So that's the first coin story. And then the second coin story is one of the local music teachers came to me and said, look, I've got this guitar. It was a classical guitar teacher who said, what I want to do is have this guitar sit on my lap in the sort of playing position without having to hold it there. And what I've been doing is I've got a plastic bag and I've just been filling it with coins, and I've dropped it in the sound hole inside the guitar, and I know exactly how much weight I need in the lower bout so that it'll actually just sit on my lap without falling over. I can take my hands off it and it'll just sit there. So I like what it's doing. I like it like that. And I hear you stick side masses in guitars. So can you now permanently stick the weight of these coins in this guitar. So I said, well, yeah, I can do that. It's going to change the sound of your guitar, though, but probably for the better. He said, well, okay. So I said, I glued in a wooden block to be able to screw the mass to. And the wooden block by itself makes essentially no difference to the sound of the guitar at all. And then you just add the mass in there. And he added quite a lot of mass. I can't remember how much it was now, but probably 300 or 400 grams of mass in there. And I rang him a couple of weeks later, said, your guitar's ready, come and play it. So along he came and played it, and he just played one note to tune as he was tuning it up. And it was apparent immediately that it was about twice as loud as it was before.
Oh, wow.
So it does make a significant difference. Oh, it was noticeably louder. So given that 3 dBs is the sort of 3 decibels, that is generally recognized as the minimum noticeable difference, I'd say we're probably 6 to 10 decibels louder.
Wow.
After that, it was that stunning. It was clearly a lot louder than it was before, and you could hear it straight away. And he was thrilled with the guitar after that. It was just significantly louder than it was before. And the reason why it's louder, there's a deep explanation of why that happens, which I won't go into now unless it's a specific question, because it's not really Falcate braced. It'll work on any guitar.
Interesting. Fantastic. We got a couple of more questions here coming in, but before we do that, I think it's time for a drawing. Let's give something away. You okay with that, Trevor?
Yeah, sure.
All right. Let me bring up Cesar. I'm gonna take you off the screen, and I'm gonna bring up Cesar. He's all the way down there in Brazil. There we are. Cesar and Manuela are back. I mean, they're in Brazil, but it looks like they're in my shop. They're using a green screen.
Yeah.
So, Cesar, why don't we give away one of Trevor's courses, the guitar analysis and testing course?
That's perfect. So, and for this first round, we have 38 participants.
All right, 38 participants.
The random number generator.
Manuela.
And let's go.
Wow, number 17.
So let's switch to the spreadsheet. And let's see who is number 17. 17 is
Lane?
Ian Carlin.
Is it Ian or
I
Lane?
think maybe it's Ian or Lane.
It's hard to tell. But whoever that is, congratulations. You have just won the guitar analysis and testing course there with Trevor Gore. So Cesar will be in touch. He has your email address, and then you will get access to that course. All right, Cesar and Manuela, thank you so much. And we'll be back on here in just a few minutes. All right, let's bring Trevor back up. Hey, Trevor's still there. You haven't gone to the beach yet, huh? All right, here comes another question for you. Let's bring this one up on the screen. I am retopping a guitar that had the top smashed. The back is glued to the sides. So if I am making a guitar top where vibrational stiffness value is 60, what frequency should I get when I tap the back? I don't know if I understand that, but maybe you do, Trevor.
Well, it's a bit of a mixed-up question. The vibrational stiffness value just gives a way of ensuring you've got repeatability in your build process. Now, that in itself won't give you a particular T112 frequency, which is a frequency you're interested in. It'll just make sure that whatever frequency you're aiming for, you keep on getting that. So if you're you don't say there whether you've got a classical guitar or a steel string guitar, but let's, for the sake of argument, assume that you're using you've got a classical guitar there. So you might be aiming for a 190 hertz T112 frequency. So you want your back to be 4 semitones higher than that. So that's the T113 frequency. needs to be 4 semitones higher than whatever it is you're aiming for your top, if you're on a live back guitar. Now, the handy thing about this is if you've got a guitar with a back on and no top, if you tap the back, you'll get the B11 frequency. That's the main resonance of the back. And the interesting thing about the B11 frequency is that it comes in just a little bit lower than the T113 frequency when you've got the top on. So if you tune the back to, say, 240 hertz, aiming for 4 semitones above 190 hertz, if you tune the B11 to 240 hertz, when you put the top on, you should end up with a frequency just a little bit higher than that. So about 242, 243 hertz. And then with a bit of brace trimming, you can bring that down exactly to 240 hertz and use various other methods to ensure that the top frequency ends up where you want it at 190 hertz.
All right. For those that are not familiar with these, with the testing, the course that we just gave away, Guitar Analysis and Testing with Trevor Gore, explains how to set up all the hardware and all the software to be able to run these tests. So go check out that course. Here comes another question. Laminated sides can add much stiffness to the rim. Will this profoundly affect the primary frequencies we strive for? Also, will it change how side mass affects things? And I know that you and me and my shop have had discussions on laminating sides or not laminating sides. Why don't you share some information about that?
Yeah, laminating sides gives you quite a lot of extra stiffness and it gives you stability on the sides, but it actually restricts you from doing quite a few other things. Generally speaking, it adds a little bit of mass as well because laminated sides on the whole tend to be a little bit thicker. The problem with that, though, is that you can't adjust the side mass using just laminated sides. You end up with what you end up with and you can't adjust it. Whereas with side masses, you can adjust the side mass and adjust the top frequency as a consequence of that. It won't affect what the side masses do, though it affects that in the same way. Now, if you add a lot of stiffness to the sides of a guitar, remember that the whole guitar body is a Helmholtz resonator. And it's not a simple resonator because a simple Helmholtz resonator works on the basis that the vessel is rigid. That means it doesn't move at all. So imagine, for example, a glass or a brass sphere like Helmholtz originally used when he invented the Helmholtz resonators. So with a guitar, you've got a flexible top and a flexible back, which tend to reduce the resonant frequency of the Helmholtz effect. Now, if you've got very stiff sides, you can't really do much in terms of affecting the flexibility of the sides if you've laminated them. Now, if you use solid wood sides, you can actually change the thickness of the sides or change how many side stiffeners you put in there, which will also affect the main air resonant frequency. So, for example, depending on how you build your sides, if you build them with solid wood and make them flexible, you can get about 2 or 3 hertz difference in the Helmholtz frequency compared with putting in side stiffeners and making the sides thicker. So that's about a semitone or more. You can change the main air resonance just due to the way you build the sides.
I think you mentioned it one time when you were here in my shop, is that you personally don't think that the effort involved in doing laminated sides is worth the results, correct?
Yeah, that's generally the case. I mean, you got twice as much work to do on the sides in terms of preparing the wood, or if you're using a 3-way laminate, maybe 3 times as much work to do in preparing the wood. Then you got to glue them together and all the rest of it, make the molds and everything else. So the things you get, the win you get with laminated sides is that your sides stay flat and stay stiff and all those sorts of good things. So you've got some good dimensional stability, but you tend to lose out on a few other good benefits of solid wood sides. So I tend to stick with solid wood sides.
Okay. Here comes a question from Rob. In the course, you use West Systems epoxy with the 207 hardener to attach the braces. Will other epoxies also work? He says, I have some West System epoxy with a different hardener.
Yeah, the other epoxies will work. West with 207. 207 is what West calls special surfaces hardener. Basically, it's a hardener which guarantees that your epoxy won't bloom when you spread it out. Remember, the West system was basically designed around boat building. And I first came across West, I don't know, 30, 40 years ago, I guess now, when I was building boats. The 207 hardener ensures that you end up with a special clear coat that won't bloom, but it also works for everything else as well. It's got a different mix ratio than the other hardeners. It's a 3-to-1 mix ratio rather than a 5-to-1 mix ratio. And I ended up using 207 for everything, just so I didn't have to have a bunch of different hardeners around, because it'll do gluing as well as surface coating. So if you're doing an epoxy grain fill, you have to use the 207 hardener to avoid the blooming. And if you're using any epoxy as a grain filler, make especially sure that you're using a special surface prep for your epoxy. And I don't know how many manufacturers actually guarantee a non-blooming performance, whereas the West 105 207 guarantees that you won't get bloom. A bloom being a sort of white blushing of your epoxy finish.
Right.
So yeah, that's why I use it. You can use it for bracing, you can use it for laminating, you can use it for surface coating. So I use it for everything, so I don't have a bunch of different hardeners around.
Okay. Here comes another question. Aiming to make a classical guitar with the tops tuned to 180 and back to 226. Are the vibrational stiffness numbers in the book, 60 and 50, are the ones I need to plug into the formula, or lower numbers? I think he's referring to that formula, the variable number in your book.
Yeah, I mean, the first thing I'd say is think hard about the 180 hertz number. That's getting a bit on the low side for a classical. I mean, certainly go there if you want. What I do, though, is use the F number that's in the book and change the height of the bracing to get down there. So rather than make the top different, I'd make the bracing a bit more flexible if you want to get down there. Usually, if you've got enough stiffness in the top to hold the tension of the strings, you end up going down to 180 by mass loading it rather than reducing the stiffness. So that's another reason to think hard about exactly how you're going to do that.
All right. Another question from Brant. For the live back, how do the secondary 45-degree braces influence the higher vibrational modes? Is symmetry critical?
And the answer to that is I don't know how they influence the higher vibrational modes because I've not really looked at them real hard. I suspect they suppress some of the higher modes because what you're trying to do is make that back move as one unit, and the sort of star braces help it do that. So yeah, you probably are suppressing them, but I don't know that because I've never really looked at it.
Okay. Here's another one. Excuse me if this question has already been asked, but I was wondering if the Falcate bracing has any foundation in radial bracing. Simon Marty, I think, has a similar background to Trevor. Is there any fundamental there?
Well, I've never met Simon, though we did work in the same physics department at Sydney University for for a while, but we didn't overlap. We didn't overlap by 20 odd years, something like that. So Simon has a PhD in physics. I've got a PhD in engineering, so we sort of do share some background. Simon's radial bracing came about, I think, and I've never spoken to Simon about this, but I suspect this is where it came from, because it was around that era. A guy called Jürgen Mayer, who's a professor of something or other in Germany, did a lot of testing on guitars to figure out what's a good classical guitar, or what made a good classical guitar. And one of the things he found was that guitars that had a prominent third resonance, as he called it, were much appreciated in listening tests. Now, it took me quite a long while to figure out what the third resonance was. Jürgen Mayer tended to use the terminology, I mean, this is back in the 1980s or thereabouts, tended to use violin terminology, where the resonances appear on a violin in a very specific order, whereas in guitars, they appear in a much more sort of random order, depending on what sort of bracing you have in there. Violins are a lot more consistent in terms of the way they've developed over the last few hundred years. So the modes of vibration always tend to appear in the same way. And so I was left wondering what the third resonance actually was. And if you count, usually you're counting up from low to high. So the first resonance is obviously the main air resonance, which is the Helmholtz resonance. Then the second resonance is typically the main top resonance. Then the third resonance is typically the main back resonance. That's a T113. The fourth resonance is typically the cross dipole, and the fifth resonance is the long dipole. So that takes you up to 5 resonances, where in my counting system, the third resonance is the T113, which is the back interacting with the top. Now, the way Jürgen Mayer did his experiments was that he was exciting the guitar on the center line, which is a node for the cross dipole mode. So he never actually saw a cross dipole because it was exciting on the node line in the center of the guitar. He wasn't using live back guitars, so he never saw a T113. So his third resonance was actually the long dipole. So having figured that out, you look at his thesis was that a long dipole made for a good sounding guitar. That was the results of his fairly involved and extensive research. Now, where does Simon fit into that? If you look at Simon's bracing system, it's discontinuous under the bridge. His fan bracing doesn't actually interlock or cross over underneath the bridge. There's actually a gap there. So what it appears to me that Simon is trying to do is trying to make sure that he's got a very active long dipole mode. And I suspect that's from the influence of Jürgen Mayer. So his bracing system is all about making sure he's got an active long dipole in there, because he's got this discontinuity in the bracing right beneath the bridge, which means that he gets a lot more bridge rotation. Of course, this is sort of fundamentally difficult with a guitar, because what you're trying to do with a guitar is limit the bridge rotation, because that's the major stress raiser on the guitar. The tension of the strings and the height of the saddle gives you a torque on the bridge, which tends to rotate the top. And I tend to use a number of about 2 degrees there. And I think if you look at Simon's guitars, you'll see the somewhat more than that. So that's what Simon was doing. He was trying to get a very active long dipole, because that's what Jürgen was recommending in his paper. Now, the Falcate system is almost exactly counter to that because it puts the stiffness right under the bridge to stop the bridge rotating. So from that point of view, they don't correlate at all. One is almost the exact opposite of the other from that point of view. Now, having that resonance where it is, the long dipole, typically comes in somewhere about the resonant frequency of your first string on a classical guitar, so tuned to E. So that's 300, 400 hertz region. And what that means is that if you want a good sounding classical guitar, you really need to have a strong first string because the melody is often carried on the first string, and it's a difficult string to make work really well. So it helps if you have a resonance somewhere in the range of the first string. And the one that Jürgen Mayer found was the long dipole. Well, the long dipole isn't a very active radiator anyway, because being a dipole, it tends to cancel a bit. And because the guitar is built to withstand the rotation of the bridge, that's how they're built, it's never going to be a very active mode. And it depends solely on the tension change in the string to actually activate that mode. So it's like the wrong way to look, wrong place to look if you're looking for something that's going to energize your first string. A better place to look is the cross tripole, because that's actually an asymmetric mode and quite a strong radiator. And also, if you tune it right, is in the first string frequency range. So what the Falcate bracing system does was put the cross tripole in the first string range, and that's how you get the treble response out of a Falcate braced classical guitar. And so in many respects, it's quite fundamentally different from the way Simon went about doing things.
Right. All right. We've got a few more questions here that I want to try and get to before we end the broadcast. I always try and keep these around 60 minutes or so. We also want to give another giveaway here. We're going to do the Falcate bracing course this time. And if you want to be eligible for that, click on that link that's in the top of the chat box there. That will get you eligible to enter the drawing. So let's try and get a few more here before we have to quit here, Trevor. Let's see. Here's one from Donald. Hello, Trevor. I have your books, and I love them. Oh, look at that. Hey, I think that deserves a little bit of applause. What do you think, huh? There we go. My question is about live backs. A lot of time we play guitars with the backs pressed against our bodies. Does this have any effect on the live back? Well, that's a great question.
Yeah, it does. It tends to dampen the back response a bit, but it doesn't kill it. So you still get some of the benefits from the live back guitar. But I mean, it's a bit like putting your arm over the top of a guitar when you play it. If you rest your hand on the bridge, like some players do, or your forearm across the lower bout, all of those things significantly dampen the sound of a guitar. And holding a live back against your body is going to do that as well. So if you really want the best acoustic effect out of a live back guitar, you're probably better off using an armrest and playing in the classical position with the back away from your body to get the best sound out of the guitar. And whilst I'm on this, a lot of people are building bevels into the top edge of a guitar as a sort of armrest effect. And yes, it does prevent the circulation being cut off from your arm, and that can be an issue. But it also puts your arm a lot closer to the top, and actually makes your forearm dampen the top of the guitar. So from that point of view, it's actually counter-effective. So you're counterproductive. So you're actually better off with one of those stick-on type armrests that keeps your arm away from the guitar if you're looking for the most acoustic benefit.
Okay. Here's somebody who wants to build a Dreadnought. Trevor, I want to build a Dreadnought size guitar with the math in your video work on the, will the math in your video work on the Dreadnoughts? And do the same Falcate bracings stay the same, or do I have to change things up? Because I think in your course, we did the OM, obviously. Do we have to change things up if we're doing a Dread?
Yeah, you do. The thing to remember about, you can use the same F numbers because they'll come out okay. If you're using the equation 4.5.7, that'll keep your top thickness where you want it. But you've got to remember that the deflection of a simply supported beam is proportional to the cube of the span. Deflection is also proportional to the thickness cube, or inversely proportional to the thickness cube, but it's also proportional to the span cube. So as the guitar gets bigger, both in length and width, you've got to size up the bracing according to the cube rule. So just remember to do that.
All right. Let's see. Coming down. Epoxy question. Epoxy depends on what you're using it for. Many different epoxies out there are available. West System is easiest to acquire with a known standard of result. Yeah, that's back to that previous question.
Yeah.
So 105 and 207 is the secret then.
Yeah. Yeah.
All right, let's roll on down here. Same question, same person. Jack, I use U.S. composites for my epoxy. I use several for different applications, layups. I use a thin 650 resin. And for other applications, I have a thicker resins I use. Okay, good. Thanks for that information. Here's one from Richard. Trevor, would you expect to see any difference in the top frequency if you build a steel string X-brace guitar with a side sound port and no sound hole compared to a traditional top? Here we go. Let's open up Pandora's box with sound ports.
Yeah, you would expect to see a different frequency. I mean, if you put a sound port in a guitar, it's probably going to be a different. It's in a different position for one, which affects the air resonant frequency, and it's probably going to be a different size for two, which also affects the air resonant frequency. And if you use a side port instead of a sound hole, you've got to have basically a side port of the same order of magnitude of a normal sound hole if you're going to get a similar sounding guitar. The problem with that is the player will hear it quite well, but you get less sound out front because the sound does radiate from the sound hole and it's radiating towards the player rather than towards an audience. So yeah, it will affect the air resonance, and because everything couples together, it will also affect the top resonance.
Okay. Here's a good question. I get this question a lot too. I've always struggled with the formulas in the book. Will Trevor ever release pre-made spreadsheets for us owners of the book who are both mathematically and technologically challenged? What do you think, Trevor?
Probably not. And the reason why probably not is that you end up with a lifetime of work supporting those sorts of software programs. I think it's important as you work through things to be familiar with the technology you're using rather than just using it as a black box. So you actually understand what's going on. And writing your own spreadsheets is a great way to really get the understanding right. And I think there's so much benefits of actually trying to do it yourself that you want to try and do that. Otherwise, you're just using a formula, like a recipe book. The whole idea of the books is that the books are a toolbox so that you can design your own instruments using some sound design principles. You'll pardon the pun, but so it's definitely beneficial to actually work through the stuff and write your own spreadsheets. the thing about the book, there is some very advanced, well, not very advanced, there's some fairly advanced and complex mathematics in there. But the whole purpose of that is that it gets you to see on the far side of the complication, and you're programming up in a spreadsheet are actually just fairly simple algebraic equations. And because spreadsheets are so prevalent, it's nearly everybody can do that these days. And if you're really technologically challenged, best thing to do is to find a mate who'll help you out with it, or get some of your offspring who are perhaps more technologically au fait with these things to help you out.
Okay, great explanation. Let's get one more question here, just real quick. We'll do a giveaway, and then we need to sign off. You may have covered it earlier, but why epoxy? I think the question is then, can you use another type of adhesive, or is epoxy the best?
Well, you possibly can use another type of adhesive, but when people have developed modern composite structures, it's nearly always been carbon fiber and epoxy. I mean, it's been glass and polyester historically, then carbon and epoxy. Now, you can probably use carbon and polyester. You can probably use glass and epoxy, but those are the standard procedures, if you like, that have been developed over the years, carbon fiber and epoxy. And remembering that as a professional guitar builder, you're building guitars that you hope to be around for a lot longer than you are. So if you're looking for your guitars to last 100 years or so, you don't want to be running a 100-year trial to see if they are actually going to hold together. So, just use the standard solution, because you know that I know, for example, that it'll last at least 40 years, because that's how long I've been using it for. So, if you want to use other mixtures of adhesives, go for it. But remember, you've got to do a lifetime trial if you want to know that it's going to survive.
Right. All right. And let's see. Tim says, thank you so much. Hope you come back yet again. Now, come back yet again. That has two meanings. Obviously, we could continue this for hours, this conversation here. I try and keep them about an hour. If not, we start losing people, and my butt starts getting sore sitting on this hard stool. But the other meaning that could have is, hope you come back yet again, is come back and give another modal tuning course. Now, Trevor and I, over the last several years, have given 8 different 3-day modal tuning courses here at my shop in Parker, Colorado. So if you're interested in having another, and right now we have no plans to do this again, but if you're interested, if I get enough emails and enough feedback here in the chat box, would you be willing to come back, Trevor, for another one?
Absolutely, for sure. Always good. Remember, we need our supporters' support for this, because to get a viable course at Robbie's place, we need to run 2, and we need at least 10 participants per course. So 20 of you guys out there, you guys and girls out there, will need to sign up before we can get a viable course. But Robbie's absolutely fantastic on the marketing of this, so he gets across to hundreds, if not thousands, of people. So let's hope we can find another 20 who would like to come to Parker, Colorado in maybe 2023.
Right.
I
don't know when I'm going to. Don't know when I'm going to do it, because my schedule is full in 2023, but we can try to squeeze it in somehow. All right, let's do a quick giveaway. I'm going to take Trevor off the screen. I'm going to bring back up Manuela and Cesar down there in Brazil. Then we'll come back. We'll say goodbye to Trevor, and we'll sign off here. So here we go, back to Brazil. Oh, well, look at that. They're on the beach now. They've left my shop and they're on the beach. Welcome back, Manuela. How's the weather on the beach?
I thought, your shop was getting a little colder, so we moved to warmer.
It is fall here, and the temperature is starting to drop.
Yeah, exactly.
So let's give away the Falcate bracing course, and go ahead, take it away.
Yeah, so just to remind everyone that we have the promo going on, so you can also use the Falcate promo code to get 10% off. And on this round, we have 60 participants, so you
60.
can
All
join
right.
60 space.
Here we go. Random number generator there by the beautiful Manuela. Number 45. Who's number 45?
So let's switch to the spreadsheet. And 45 is on here. Tim Crawford.
Tim Crawford, congratulations. You have won the Falcate Racing course. Hey! And so Cesar will be in touch. For those of you who do not win the Falcate Racing course, use what's the promo code, Cesar?
Falcate.
Falcate. Very difficult promo code. Just go to luthiacademy.com, click on Falcate, or click on the online course. Use Falcate at checkout. You get 10% off. All right. Thank you. And Cesar and Manuela there in Brazil. I'm going to come back to my screen now.
Thank you.
And let's bring Trevor back up one real quick. Trevor, oh, look at that. Drew Boyd's here. Drew Boyd's in the house. Drew is also on the Luthery Academy Advisory Committee, as well as Trevor. Trevor's on the Luthery Advisory Committee, Luthery Academy Advisory Committee. And I think we could have, Trevor and Drew back on here multiple times, and we could, have a lot more fun and answer a lot more questions. So thanks for tuning in there, Drew. Before we let you go, Trevor, I'm sure you've got a full day of work in your shop and guitars to be built. Have you got any final words of wisdom or advice for us fledgling guitar builders?
Well, I'd say study the background of the beach down there in Brazil, because there's some fascinating standing waves down there, because the waves don't actually move. The trees do, but the waves don't.
We'll have to work on that green screen.
Critically important to understand the significance of standing waves in guitar building. So that's something to think about.
I actually had a guy, I don't know, he may have been in your class, Trevor, that actually studied waves. Who was that?
Right. I cannot remember who that would have been.
I think he took your class here at the shop.
Yeah, I think every course we've had at least one NASA scientist on, which is fascinating.
Yeah, it's pretty amazing who we come to the shop here. All right. Well, Trevor, thank you so much for, donating some of your time here this morning and getting up early there in Sydney. Thank you to Cesar and Manuela down there in Brazil. Final goodbye to them. Oh, they're back in my shop. Look at that.
Yeah, we're right.
Thank you for doing the drawings there. Cesar will be in touch
with
everybody that has won. And Paco in Spain says, Grande Cesar. Look at that. Thank you, Cesar and Manuela. Boy, I am always amazed at how our reach here. I mean, Paco's in Spain. Oh, by the way, Paco's on the Luthery Academy Advisory Committee as well. So Paco's in Spain, Cesar Manuel in Brazil, Trevor in Sydney. I'm sitting here in Colorado. We got people from all over the world tuning in. So thank you once again for doing that. And remember, October 26th? October 26th at 10 a.m. Mountain Time. The Pacific Rim Tonewoods folks will be online here. Trevor, you may even want to tune in. Oh, no, it's going to be like 3 or 4 o'clock in the morning for you, huh?
Well, I definitely recommend listening to that, because they're great guys at Pacific Rim Tonewoods there. They really know their woods, and they really know what's going on. So that's going to be fascinating. And if I'm up at that time of day or night, whatever it figures out to be, I've not worked it out yet, I'll certainly be tuning in and listening to that one, and listening to Dave Olson if Dave's along as well as.
Yeah, Dave will be there. Also, Eric.
Yeah, excellent.
All right. Thank you very much again, folks. Excuse me, for tuning in. And over and out. Bye-bye. See you next time. Bye, Trevor.
Thanks, everybody. Thank you.